Okay, Math 9, here we go. This is our sixth full e-lesson video, and we're going to talk about fraction basics. I'm going to break it into three littler videos, but this one's going to be fraction basics and their relationships to decimal numbers. So here we go. First off, people get a little nervous and worried and scared and just frankly angry when we start talking about fractions. But there's nothing to be overly worried about if you just think about your numbers 1, 2, 3, 4, so on and so forth. Obviously, oh, let's put 0 in there too. Obviously, there's numbers in between those because we all understand 1.5 and 2.5. I mean, you ask a kid when they're 7 how old they are. Oh, I'm 7.5. So they're already kind of dealing with fractions. They just don't realize it. So we're going to focus on proper fractions right now. And a proper fraction is when you have a numerator, the top number, which is smaller than the denominator, which is the bottom number. Okay? Because where that puts us is that puts us in this chunk between 0 and 1. So every number less than 1 is a number greater than 0 is a proper fraction. So what it means is you got to think about this partition from 0 to 1. The partition from 0 to 1 is always the same size. So when you're talking about fractions, you're assuming the fact that every whole, every one, is the same size. And what you're doing to that is you're breaking it into small chunks. And you're breaking it into chunks of size 12. So you can say a 12th of 1. Or you could say I'm breaking 1 into 12 little chunks. And each chunk represents 1/12. So you'd be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you can now there's 12 little chunks of 1 that are all equally spaced, evenly spaced perfectly. Pardon my drawing. And what we have in this case is we have 7 of them. 1, 2, 3, 4, 5, 6. We have 7 out of 12. That is a fraction. Now, what's it easiest to look at? Well, it's easiest to look at a half. We all know a half. A half is you have half of something. So if we had our 1, right? So say we had our 1, and I'm going to try my best to draw them by hand, about the same size all the time. But so there's your 1, 0 to 1. Well, a half is you're splitting it into 2, and they are the same size. So if you have 0 over 2, 0 out of those 2, you have 0. So we're not coloring anything in. If you have 1 of those 2, you have what looks like this, which is 1/2. That's all a fraction is. And then when you get to 2 out of 2, well, that's 1. So you have the whole thing again. That is a fraction. It's part of the 1. It's what that looks like. So don't freak yourself out about the fact that it's just a number between 0 and 1. There are particular ways to deal with them and to operate with them, which we're going to talk about in the videos to come. But you got to come into fractions with an open mind here because, yes, it's a little bit different than whole numbers, but some of their properties are very, very similar. So let's look at proper fractions as a visual. As you can see in this box, on the left, I just have a portion of a box shaded. And you can see these two boxes, this box here, like the whole box and the whole box, are the same size. But the box on the left, this one here, doesn't really give me much information. All I know is I have less than 1. But if I break those partitions into even spaces, like I have here in the second one, you can actually start giving it a value. And you can look at this a number of different ways. Look at the total number of of boxes in the grid here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you've broken 1 into 12. And then all you're looking at is, well, how many are filled in? Well, 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 out of 12. So that box represents 8/12 of 1, right? Which is more than half, but not quite 1. You could actually look at this a different way, though, and this is how you can start looking at visuals of fractions. Rather than look at them as the individual little boxes, you could go like this. Okay, I have a column, and a column. So I have 3 columns, and 2 of them are full. So that means we had a fraction 8 over 12, but we also have a fraction 2 over 3. Now you're going to see how these are related when we do an equivalent fraction section. You could look at this another way as well, right? How you break these things down is totally up to you. You could have a row right? And then you're going to have each row, and you're going to have 4 rows. The only problem with looking at it as rows is, are your rows full? They're not. So you can't kind of come up with a fraction value looking at it that way. You need to make sure that when you're breaking it into the same bits, that everything's full if you're going to make a fraction out of it. But one thing you might notice is you could go like this. Squares. 2, 2, 2, and 2. So you have 6 of these squares, and you have 4 of them. So that's another way to look at it. And then we'll leave it there for that, but that's how you can consider equivalent fractions. All of these fractions have the same value. We'll look at why, but it's because we can represent it visually like that already. It's helpful to represent it visually, but remember that every piece is the same size. So now let's look at this visual. Okay, what fraction is represented by this visual below? And let's look at it in a couple different ways. One, how many small boxes do you have? 1, 2, 3, 4, 5, 6, but then 4 deep. So that means we have 24 boxes. And then how many do we have filled in? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 of 24. What's another way we can look at this? Well, we have 1, 2, 3, 4, 5, 6 columns. And how many do we have filled in? We have 2 of them filled in. So that's another way to look at it. We could look at it another way, and we could say, well, we have 1, 2, 3, 4, 5, 6 boxes, right? Similar to our columns, but we're looking at them as boxes. And how many boxes do we have? Again, we have 2 of 6, so you end up with the same fraction. You could break these into another way. Rather than look at them as very, very small boxes, you could look at them as pairs. So you have 1, 2, and then you'd have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 12 pairs, and you have 1, 2, 3, 4 of them. So again, we have another representation. So you see, you can get quite a few different representations by partitioning your filled versus unfilled section equally. And it gives you all different fraction possibilities, but they all are going to have the same value. Again, you'll see that in our equivalent fraction section, but that should make intuitive sense for you looking at the visual. Okay, so now most of the people I talk to are much more comfortable with decimals than they are fractions. But the thing with fractions is fractions are much more exact than a decimal is, because every single fraction can be written as a decimal that either terminates, so 0.25 or 0.5, or a fraction that repeats. And the most common that people think about is 3, 3, 3, 3 forever, which we would write as 0.3 with a line over top of it. But you can also have decimals that repeat large strings of numbers. So you could have a decimal expansion that looks like this. And that 4, 5, 1, 2, 3, 7 just repeats over and over again. So what you do is you would cut it off here, and you would say all of that repeats. But if you key that into your calculator, you're going to round that. But the thing is the rounding makes it less exact. The fraction is going to be completely exact. So let's look at how we can create decimals from fractions. And it helps by thinking this dash. Now, a lot of people say, okay, this means 4 over 5, or 4, I've heard people say on 5. Or sometimes you'll even get 5 under 4. That's so strange when we don't really say often, but 4 over 5, 4 out of 5. But the big one is that is 4 divided by 5. You have 4 things, and you're dividing them into 5 boxes, right? So if you had your 1, for instance, your whole, and we split it into 5, you have 4, you're putting 4 things in 5 boxes. So you're dividing 4 things amongst 5 spaces, which is why we have less than 1. So in order to do this properly, it reads 4 divided by 5, which means 4 divided by 5. And now we're back to our division. Now, I posted a video on division, and this is going to be the same process, except we have one extra piece. because when you start this, and to know whether or not you set it up properly, which means you put the 5 and 4 in the right spot, you go 5 goes into 4 how many times? And you should always get 0. If you had the 5 here and the 4 here, you'd get a 1, and you should know that your question is wrong because you have less than 1 here. You have 0 point something. So you put a 0 and then throw a decimal, because then you can include as many zeros as you need to. You'll see this in the next couple examples, because 4.000000 is still just 4. But now we can bring that extra remainder and say how many times does 5 go into 40? And in this case, we get 8, and 8 times 5 is 40, so no remainder. So that means that 4 over 5 is equal to 0.8, a terminating decimal. So it's just division again. So I know some of you are moaning and groaning, but that's how it works. Now let's look at a couple more examples. 3 over 8. Well, that's 3 divided by 8. 8 goes into 3 0 times, put our decimal and our decimal, and then tack on as many zeros as you're going to need. So 8 goes into 30 3 times with 6 remainder. 8 goes into 60 7 times with 4 remainder. If you're not sure what I'm doing, go back and watch my video on short division. If 8 goes into 40 5 times with no remainder, which means that 3 over 8 is equal to 0.375. So again, this is a terminating decimal, but it can be represented as 3 over 8. And we got one more here, 4 over 7. So we are going 4 divided by 7. You know you're going to need this decimal, so let's put it in here. And I'll throw some zeros down. So 0. So now 7 goes into 40 5 times with 5 remainder. 7 goes into 50 7 times with 1 remainder. 7 goes into 10 once with 3 remainder. 7 goes into 30 4 times with 2 remainder. Now this looks like it's going on forever, and it could go on for however long it goes on for. We're either looking for a point where this stops or where we see a remainder we've seen before, because then we hit what's called the repeat point. 7 goes into 20 twice with 6 remainder. So you can see we're dealing with number 60. I haven't seen 60 yet, right? I have 40, 50, 10. So still keep going. 7 goes into 68 times with, 4 remainder. So here I am, the number 40. Well, it goes in 5. But I've seen that before, right? I've seen that at the very beginning. So this is my repeat point. So it means that 4 over 7 is 0.57148, and all of that repeats over and over and over again, which is why that's a bit of a mess, and this is much cleaner. Fractions are lovely things. Let's get comfortable with them. Thank you so much. Next video is on equivalence and comparing fractions, which we mentioned briefly in this video. And always feel free to go back and watch the division video for help on dividing fractions to get decimals. Thank you so much.